The inverse is the one you want to go from here to here. From here to here. You want to put 1/2 here and find -1. So essentially, what's the meaning for logarithm? That means if the base is 2, you are given y, you want to find x. If you are given 1/4, you want to find out -2. This one will be denoted as f inverse. Okay? So the conclusion right here is that here for 2 to the x, for each x, here, you see right here, you have a y. Now, the inverse would be like this. You have a y given here on this side. You want to find x. Okay? With the same base 2 in this case. How are we going to express x by y? You can see here we express y by x. How are we going to express x by y? So then we have to use some new notation, new concept. This concept will be logarithm function. So we do it this way. We express x by y is like this. It's still 2 to the something. It's still here is 2 to the x, and 2 is bigger, x is smaller. Here we do 2 to the y. Okay, y is smaller, 2 is smaller, y is bigger. Here 2 is bigger, x is smaller. Okay, but sometimes it's hard to see which one is bigger, which one is smaller. So let's put log in front of it. Okay, put log in front of it. Okay, so in this way that we use y to express x. So if you have a y equals 2 to the x, how to express x? So we do is we use log. That's logarithm function, the sign of logarithm function. But still we do log base 2 to the y and put x in front of it. And x, remember here, is the exponent. Okay? Basically right here is that if you have a log base 2 to the y, is that you want to find the actual value for this, let's say denoted by x. This x will act on as an exponent of 2, and you get y. So this logarithm is basically to find out the exponent. That's the meaning for the logarithm. You see this case? 8 equals 2 cubed. Okay? And then here we use x to express y. How to express x by y? We do the same thing. 2 to the 8. But here we put logarithm in front of 2. So we do log base 2 to the 8 and then exponent. That will be the final answer for log base 2 to the 8. Okay? So this one, if you put 8 here, you should be able to go back to find out 3. Okay? Now, here are all the things we put together. Okay? Now look. Here we have a 8 log base 2. Log base 2 to the 8, we know it's 3. Yes, you know. 2 cubed is 8. And then here we do log base 2 to the 8 is 3. The same thing right here. Now similarly we can do the same thing for the rest of them. Okay? You see right here, that's 2 squared is 4. So for the logarithm function, we will write log base 2, we use this base 2 to the 4, and we end up with the exponent, this 2. Okay. Now, okay. Here is 2 to the first, which is 2. And then we do the same thing. This is the base. So we do log base. This 2 is this 2. 2, this 2, that's right here. That would be the exponent, is 1. So log base 2 to the 2 is 1. Okay? Yeah. So remember, 2 to the first power equals 2. Then we got that. Okay, similar for this case. 2 to the 0 is 1. Then you know log base 2 use the same base. Because 2 here is fixed. So we use the same base. Now log base 2 to the 1, the exponent has to be 0. So we put 0 here. Okay? And so is the case right here. See, base is 2 to the exponent -1 is 1/2. Then we do log base 2 to the 1/2 is -1. That's the exponent. Okay? And the case right here is exactly the same. 2 to the -2 is 1/4. So then log this base 2 here, 2, and here is the same base 2 to the 1/4 is going to be the exponent, -2, because we know 2 to the -2 is 1/4. Okay, so this answer actually eventually logarithm is go back to find out the exponents. All those are exponents. You see right here, -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. All those are exponents. Okay. All right. So that's the logarithm function. That's the logarithm function. So you know we like to express our independent variable. Here normally we like to use this one to be x. So that's why I put x here. X choose all those different values. And then here should be used x. And then this one is y. We always use the answer we input it over there is the x independent. And the variable, the values of variable, that variable output, we always use y. Okay, so that's why right here we write log base 2 to the x, okay, instead of y. And the answer is y equals that. Y is the output. So this function y equals log base 2 to the x will be the inverse of this one. Y equals 2 to the x. Okay. Now, how about the graphs? Look. We have an exponential function. That's -2, 1/4, -1, 1/2 is right here. Okay. -2, 1/4. Where is that? -2 right here. That's for x. Okay. So we will write -2, 1/4. Where is 1/4? Here is 1/2. And here is 1/4. So this point. -1, 1/2, -1 right here. So this will be -1, 1/2. Slightly higher. Okay. And then 0, 1. Okay, that's this point. 1, 2, this one. 2, 4, this one. 2, 4, this one. 3, 8. Okay, 3 is here. And 8 is this one. So that's the point. You connect it. That's the exponential function. And we know that the inverse function of the exponential function is symmetric to this picture y equals x. So basically symmetric is you flip this curve, this one, based on this line, you get another one. Okay, and here is the reason. You see right here, x is 1/4, where y is -2. Okay, then we have here x is 1/4, which is positive. X is 1/4, that's on this one. This is x. All right, and then you have a -2. Y is -2 is right here. So this point, 1/4, -2 right here. 1/2, -1. 1/2 is here, -1 is here. So that's the point. Okay, 1/2, -1 right here. 1, 0. 1, 0 is right here. Okay. Let me put 1, 0 here. 2, 1. So 2, 1. 4, 2. So 1, 2, 3, 4, 2 right here. 3, 8. Okay. 3, 8. Then you have a 8, 3. So you have a 8 and then 3 this high. So this one. You connect it, you have the curve. So this one is y equals log base 2 to the x. This one is y equals 2 to the x. One is the inverse of another. Okay, so this is the picture for y equals log base 2 to the x. And this is the picture for y equals 2 to the x. One is the inverse function of the other one. Okay. Hopefully we get the idea for the logarithm function is to find out the exponent. You got to remember that. Logarithm is to find out the exponent.